Assalamualaikum. Today I will make a video about emerging IT technologies. So my own emerging IT technologies is electric bicycle. As you can see right now, electric bicycle is the most trending technologies for bicycle. It has lots of features and you can see right now everyone ride them. So, without further ado, let's jump right into it. Okay, the introduction. Assignment background. Electric bicycles or e-bikes combine traditional cycling with electric propulsion, offering faster, more efficient transports. Their adoption followed an S-curve, slow at first, then rapid growth, and finally marked stabilization. Over the past decade, e-bikes have become mainstream in cities and rural areas. A second S-curve is emerging, featuring better batteries, motors, lightweight material, and smart technology like AI road optimization and IoT connectivity. This enhances user experience, safety, and efficiency, with government and private sectors investing in cycling infrastructure and green mobility. E-bike adoption is expected to grow even faster. Understanding this S-curve helps manufacturers and policymakers plan sustainable mobility solutions. Source material. Adapt from concept discussed in Roger E.M. 2003 Diffusion of Innovation and Industry Insight from Deloitte Insight. The Second Curve of Transportation Technology 2022. Okay, the objective of this assignment is to perform data pre-processing of recent trend in emerging technologies using S-curve to compare various technology effectively to produce a presentation on technologies. Significance of studying electric bicycles e-bikes is important for technology, society, and the environment. E-bikes provide sustainable transport, reduce traffic and pollution, and offer accessible mobility for all, including older adults and people with physical limitations. Understanding adoption patterns through the S-curve help policymakers and manufacturers plan infrastructure, improve design, and encourage eco-friendly commuting. E-bike also connect to innovation theory, showing stage of growth and opportunity for advanced technologies like AI assist riding and smart connectivity. Widespread adoption support lower emission, healthier lifestyles, and sustainable urban mobility, making e-bikes a key tool for social and environmental progress. Credit for conceptual inspiration. Adapt from Roger E.M. 2003, Diffusion of Innovation and Deloitte Insight 2022, The Second Curve of Transportation Technology. And the result and discussion. Result finding one electric bicycle. The adoption of electric bicycle e-bikes has experienced significant growth over the past decade, reflecting the dynamic of technological diffusion as described by the S-curve model. Early adoption was slow due to high costs, heavy battery system, and limited consumer awareness. However, improvement in lithium-ion battery technology, motor efficiency, and frame design have accelerated adoption, particularly in urban areas where congestion and environmental concerns drive demand. Also, result and discussion. 1.1.1 S-curve of electric bicycle. For the first curve, the result section simplify and objectively report what you discover without speculating on why you discovered this finding. The discussion interpret the meaning of the result, place them in context, and explain why they are important. So as you can see, the efficiency is between 1895 to 1990. So for grown, it starts from 1990 to 2010. So for maturity, it starts from 2010 to 2020. So for the sunset, it goes higher than that. It goes from 2025 and above. So trend in electric bicycle. 1.5.1 infancy stage oldest technology. Around 1895, inventors began experimenting with electric power bicycles using crude DC motors and lead-acid batteries. These early prototypes were heavy, slow, and had very short range, often just a few miles. Bicycles were mostly novelty items or demonstration projects rather than practical transportation. 1.5.2 Chrome stage older technology. Around 1990, e-bikes become commercially available in small numbers in Japan, Europe, and the US. Early models used lead-acid or nickel cadmium batteries, which limited range and performance. They attract niche customers, mostly enthusiasts or urban commuter looking for alternative transport. So for 1.5.3 mature stage old technology, e-bikes were widely available in Asia, Europe, and North America with consistent design and features. Batteries have shifted mostly to lithium-ion, improving range, weight, and charging speed. Commuters increasingly view e-bikes as a practical daily transportation option. Government in Europe and China introduced regulation and safety standards, further legitimizing the market. So for 1.5.4 sunset stage, the newest technology, smart e-bikes with integrated displays, GPS, smartphone apps, and IoT features gain popularity. High-performance motors and long-range lithium-ion batteries make older models less competitive. Many manufacturers phase out first-generation design to focus on new tech-enhanced e-bikes. Urban shared e-bike programs increasingly adopt modern fleets, further reducing the demand for older models. So the impact of electric bicycle on daily life, no more traffic jams. These are getting more and more popular in cities as government and council urge people to give up their cars. As they are fast, it is highly recommended to wear a full face bike helmet. Number two is provide convenience. E-bikes are now popular with the elderly because they are less stressful and comfortable than ordinary bicycle. It is also safer to use. Number three is climate benefits. E-bikes emit lower pollution per kilometer than motorcycles and cars. You can help by using an e-bike instead of a petrol of, or diesel car. Number four is pedal assist. E-bikes have what they call battery power pedal assist technically. This is a machine integrated within the bike to give your pedaling a boost. For source, you can check this out. Maturity model analysis. The maturity model categorizes electric bicycle into four stages: infancy, ground, maturity, and sunset. Each stage reflects the level of technological adoption, innovation, and market penetration. Infancy: heavy, bulky, primitive, batteries, lead-acid, minimal range, mostly single speed with crude control system, no advanced electronics. Grow: lithium-ion and mid battery began replacing lead-acid, reducing weight. mature lithium-ion battery that improve longer range 100 km, shorter charging times, integrate frames for sleeker designs, sunset ultralight carbon fiber frames, hidden batteries, and powerful mid-drive motor. So for the second S-curve of electric bikes, as you can see, for after sunset, it it just show you what is the future of technology after electric bike. As you can see, right now we still have electric bike, but for the future we could have a smart AI electric bicycle, hopefully. Full-feature technology replacing electric bicycle in the infancy stage. Next generation e-bike with ultralight and AI assist. Ultralight frames made from graphene composites or advanced carbon nanotube structures, reducing total weight to under 10 kilogram without sacrificing strength. Solid-state batteries replacing traditional lithium-ion offering up to ta- up to 1,000 kilometers range per charge, depending on riding condition. So imagine technologies and innovation in ultralight and AI assist electric bicycle, the integration of artificial intelligence AI into electric bicycle marked the beginning of a new mobility area, enabling smarter, safer, and more personalized riding experience. These innovations are still emerging, but they are shaping the future of next generation e-bikes. Also, it will use AI-powered adaptive pedal assist, like use real-time sensor data, Tokyo cadence, heart rate, slope, wind speed to automatically adjust motor assistance without rider input. Impact of e-bikes with ultralight and AI assist technology on daily life. The first one is ultralight frame, often under 50 kg, make e-bikes easier to carry upstairs, store indoors, and or place in public transport. AI assist system adjusts power output according to rider capability, enabling elderly individuals, those with mobility challenges. AI caution feature can track calories burned, heart rate, and cadence, offering personalized riding goals. Ultra Ultra-light frames require fewer raw materials in manufacturing and are easier to recycle. So the conclusion is the electric bicycle or e-bike has undergone a remarkable transformation since its earliest prototypes in the late 19th century. From the heavy rudimentary design of the 1890 to today's ultralight AI-assist smart models, the technology has progressed through a series of innovation cycles that can be clearly mapped to the technology S-curve model, a framework describing the life cycle of a technology from birth to decline. By understanding this S-curve perspective, we can see that electric bicycles are not just evolving in form of and function. They are cycling through stages of innovation that redefine their role in society every few decades. The journey from infancy to the present day illustrates how breakthroughs in materials, energy storage, and artificial intelligence continue to shape the future of mobility. So, for the reference, you can check this out. We have a lot of links for you to check. So, thank you guys.